Right, here we go, Stinky. Are you ready for this? Brace yourself. Okay, rule number 1. New component, so that all of the features become owned by this component. Makes it easier for editing and organising your timeline later. Sketch, rectangle, and go with a centre point rectangle. And you know what, I don't know how big I want it yet, so let's do some parameters, create some parameters here. User parameters, base plate width, and we'll go with 150, and dovetail width, go with 30, dovetail height 15, dovetail angle, and this is, you have to remember to change the unit here. You can't change it afterwards, which is kind of annoying, but degrees, and we'll go with 15, and let's go with hole size 6mm, and base plate thick, and we'll go with dovetail height plus 15. This should be good. Alright, so dimension this, and we're going to go with base plate width, and then we'll use an equals constraint between those two there and extrude this up by the base plate thick. Now we can do a sketch on this face here, plane here, this face, and we'll start drawing dovetail profile. We'll get it, and then do a line between the midpoint to midpoint, X for construction, and then we'll make that vertical, and then dimension between here and here. I'm going to go dovetail angle, and dovetail width, dovetail height, and then we can make this coincident with the origin of the sketch, and this coincident with the top. We'll make it collinear with the top of this here. Alright, so now we can extrude that profile and cut it through all instead of a distance, and that will do. And then create pattern circular. What do we want to do? Features axis around the Z axis, because we modeled this on the 0, 0, 0. Going to go with 2, and we need to type in an angle of 90 degrees, and that's it, done. So this part's finished, so we can come back up to the top level, right click on this one and ground it, and now we can turn back on that sketch that was in here and actually reuse that sketch. So now we can extrude that out for a new component. Okay, new component, and we're going to go minus dovetail width, turn off that dovetail block, and then edit this and put that hole in there. So pull up a plane off here, 1mm, just to allow for that washer. I'm not going to actually model that washer. Create sketch. Now this is actually the sketch origin, and I just want to make sure I actually capture the center point, the midpoint here. So draw a line from here to here. I'm going to turn off this other component just to make sure, turning off the other component to make sure that I don't snap to something I don't want to. And we'll go, yeah, there we go. Perpendicular between these two. What? Some kind of craziness. Line from there to here again, and we want that to go to the midpoint. Right. Perpendicular between here and here. There we go. We don't have to make this construction, but we will. Stop the sketch, and now we can create a hole, and from sketch points pick that point there, go through all, and the objects to cut, there's only one visible, so it's only going to cut through this, which is what we want anyway. And actually here we're going to go for hole size. There we go. Alright, so that's the dovetail block finished. You can turn the base back on, come back up to the top level, and now we can do a new component, so I want to create a new sketch rather than reuse one. And I actually want to build my sketch up off of this plane here in the other component, so I can do that. I can right click, create sketch. That's the beauty of Fusion. And I don't want to use this sketch reference because I want to make sure that when things change that it uses the model geometry, not the sketch origins. Okay, so, and that's going to maintain my 6mm there as well. So now I can go circle, and I'm just going to draw one off to the side here, and again just to make sure that it's tied to the circle that I've brought through, and dimension this out 60mm. Now here's one of the areas where you made a mistake, and I can offer you a tip. So we'll just draw that circle there, this one here, and another one out here. This one will be 25, and then these are all equal to one another. This one's currently free to move wherever you want. We know that that's going to be on the center line here, so that is also this point here. So if we go project, P for project, and I pick that, the model origin, I can now tie this down to there and make this vertically constrained to there, and the dimension we want to use for that is from there to here will be base plate width, and we'll go plus 20mm. Okay, now it's drawn that this is the tip. So if you left click on the coincident, okay, and move around, then it's just going to the line's going to rotate around that point that you've selected. But if you hold down shift, it will snap to tangent, which means that you can come over here and grab the tangent C at this end, and now you've got a line that's between two circles and both ends are tangent. It's a pretty sweet little tip, that one. It's quite handy specifically for this type of sketch geometry. So again, holding down shift, I'll repeat that. So line, left click to place, and then hold down shift, and it will slide around tangent, maintaining tangency, and then snap the tangent on the other side. And I made this bigger just so it was easy for me to do that. So now I can come back to here, 30 degrees, extrude these two profiles, and we'll go up 5mm, and it's a new body within this component, so that's what I want. Okay, I'm done in this component now, so we'll exit out of here, we'll call that crank arm. And now let's just, for the hell of it, let's just make a handle. Your technique with revolving and that followed on from things nicely, from your previous videos nicely, so that was cool. I'm just gonna do a T-spline one though, so create form, cylinder. I'm gonna pick this face to drive it off, and that mid center point. I'm gonna come out to here, drag it up. 50 mil, 45 mil. Add an extra face and then just start doing some. We'll double click that to select the profile, edit the form, and then just scale it in slightly, and we'll do the same thing. So I held down control then so I could double click and select that one, and then this one here we'll make a bit bigger, and I'll scale it up to the top somewhat, and then do the same thing here and start just pulling it in as close as I can. Yeah, there we go. I think we can actually weld all those points together if we want, but I'm not going to. I'm just going to finish the form, switch into the patch environment, create a patch on the top edge here, use tangent, it's all good. Do the bottom one as well, so repeat patch, do the bottom, don't want it to be tangent, want it to be connected so it stays flat, and then go modify, select those three bodies, convert it into a new part and into the model, and now we can do a cheeky little let's just do it on here, cheeky little fillet. Let's do a chamfer, sod it, go with 0.25 chamfer. Can't see it. 0.25. There we go. So that's the handle. All done. Come back up to the top. Right, so as built joints, these are pretty cool because I've modelled this in place. I can come in here now and go as built joint. This part's grounded, and I need to do this part here. It needs a position, so I'm going to pick that position there, and I want it to be a slider, and there we go. Okay. And as built joint again, this time between this one and this one here, and the position is going to be, it can really be anywhere, but in fact I'm gonna do it up here. Look, okay. This is revolute, ideal. So I'll do, and we'll repeat the same thing again. This time we're going to pick these two components, and it's going to be rigid, and it doesn't need a reference for that. Okay, so now we can rotate this around, and we can slide this one backwards and forwards. So now let's copy this dovetail block, continue, and we'll just pull this out here and go okay. Right, this time we're going to use one of your joints, and we'll pick up on this face here and this face here. Flip it around. No, we don't want to flip it around. That's just because of the here we go. Yep, so we don't want the offset of 1. Go 0. It's picked up on 180 degrees because I can, it's just remembered from when I did that just before. And we want it to be a slider. Okay. If we want to offset it in the Y, just to line things up, could go minus dovetail width if you wanted to. So that's parametric as well. And okay, right. So now we need to tie these two points together. So we can just slide this backwards and forwards, no worries. So if we do another joint, and this time we're going to go component 1 to component 2, and it needs to be revolute. We just need to zero out all of this stuff, and we need a, this is going to fail, so we actually need a 1mm offset in here to account for that work plane. Probably should use a parameter there as well. There we go. So now we can just go around and around and around. It's all done. So what happens if we change some of these parameters? change that to 200. Here we can see there's an issue with my original sketch. So it looks like my hole has failed, right? So if we undo that, where has my hole gone? So it'll be because of yeah. For some reason it didn't remember to reconnect my hole. And this one here is throwing a bit of a wobbly as well, so that's because it was what kind of joint did I use for that? Rigid. So I should have probably used a revolute. Yeah, I shouldn't have used an as-built joint there. Joint, continue, and go from here to here. Okay. Oh, I should have deleted that one first, eh? There we go. Right, let's try that again. So, that's the thing about all this parametric stuff, is you've got to make sure that you bring through the correct references. So we go back to 150, sweet as, 200, 250. You can change the dovetail width to 35, dovetail height to 20, dovetail angle to 10. See if our hole height size will change. Yep, and inside there as well. Yep, beauty. Go 8. Let's go back to 150. 30 and 15. Anyway, you may not want to do all the parametric stuff, that's fine, but I just wanted to show you a few other tricks and ways to save on the number of sketches and components, really. So yeah, cheers man.